Good morning, good day, and this is February 22nd, 2021, Monday. And this is your friend Engineer Suraj Singh. Sorry. Sorry. This is Engineer Suraj Singh, your friend speaking from Bharat, India. Bad weather, of course, sometimes cold, sometimes hot. And this is regarding quality issue in professional engineering and otherwise. Usually, I have a habit to address community daily early morning. I find it better due to many reasons. That early morning it's fresh time and people are sleeping. And I can't stop that, but early morning is a better time. Environment is soft and it is quality time, you can say. No pollution. Early morning, of course, means there is pollution, but not fresh pollution. And you can sit freely, you can talk freely, you can think freely. That's most important point. Civil field engineering designs, construction methods, contracts, EPC, AnnexSL, organizations, communications, coordination, quantity, quality, and why should we be behind quality of concrete, standard material, and all others. Another talk in sequence, probably 272 number. Number is not important, but issue is important. Quality, which everybody is hungry for. If you are not hungry for quality, I think your stomach has digestion problem, because if you are intelligent, brilliant, professional, and even non-professional, there is no one in this world who doesn't like quality. And if somebody doesn't like quality, well, I can't comment about that because there are exceptions everywhere. Quality, though it's not described separately, when I say quantity, times again I say, it's understood that quantity must include quality. If that quantity, that product does not have quality within its two requirement, that product is not acceptable, that product must be rejected, that product is substandard, that product is not good for health where it's going to be used. Maybe it is your consumption of food, or it may be your structure, or it may be your car, or in wherever else you use that product, that won't work according to its intended purpose. It won't satisfy, it won't give you service as required. So quality, though it has been there for centuries, for millions, quality criteria has been there, but very well educated people now we should give more quality, but it has not happened. It has not been happening, you can say. I have more than 40 years experience. Now I am 66 years old. You can say post graduation experience. I qualified my first diploma in 1974 and then my engineering degree in 1980. So you can say now 82, you may say, to 20 years, and these 21 years, about 40 years or more post graduation experience, and about, you can say, 45 post diploma experience. And I am now proud that I enjoyed profession of my civil engineering and interdisciplinary engineering through my career, and I still remember each and every activity that passed through me, whether I was in this country or I was overseas in many countries like Iraq, Libya, Qatar, UAE, or wherever I was. I tried to learn a lot, and a lot. I try to learn from more than 50 nationalities and different type of specifications, different standards of drawings from scratch to modern, and you can say very updated computerized work. I started learning my computer in 1996, 7, you can say, 98, probably 98, I'm sorry, 98 end or 99. I started learning computer, and by that time I was not even aware of what computer was. One of my senior in Doha sought me, please learn something, Suraj. It will make your life easy and my life easy. But I did not prefer. I said I can do better than computers. Yes means no, you are not cooperating this and that. But I had to do quantity surveying manually. I had to do designs manually. I had to do whatever work was required to be done manually, and I didn't mind it. Means I was used to that. You see, from 74 onwards to 98, about 20, 74 to 98, it was a long period that I had undergone manually, from log table to calculator, and then working like that. And of course site is for same, there was no difference. Concrete was concrete, production method may be different because it came from batching plant. So batching plant were computerized probably. Otherwise side mixing was done, which was calibrated by mixer, hopper. So it was a mixed experience. But but we were specification oriented, we were quality oriented. Those who try to do work with quality, and particularly those working in contracting company like me, was taunted by seniors and others. He is a consultant, he is not our person. Such a joke was passed through many people, Arabic people particularly. He is working for consultant, or he's not working for us. Because in profession of contracting, everybody seems to be crooked to some extent. Everyone, they want quantity, and if they think it's approved by consultant, it's done. You got my point. What's the common thinking was, if consultant or engineer, we call engineer or engineer's staff, approves, it's final. But because they never had studied law, they never have studied contract conditions, they never had studied what contract was. They were fieldmen, maybe foremen, maybe general foremen, maybe others who used to work directly on front, backed by ourselves. They used to think that I was not good for them because I was asking too much about specification, about quality, and I was interacting a lot with consultants. So they called me, you're a consultant person. Even my senior, who was from Lebanon in 1986, I think, yes. When I joined in 1985, 86, 87, yes. He commented on my remunerations when I was closing that contract and getting another one. I was going on vacation, he has to pay me some bonus. So he told me, see Suraj, I wanted to pay you 1 month more, but because you are a consultant, you are another contractor, I can't pay that. I said, no problem, thank you very much, don't worry. Whatever I am, I am. But he was compelled to keep me there because of various contractual reasons. And he liked my work, my dedication, my mind, and my performance. He liked all that. But because he was a manager having some partnership, so he wanted to share more profit. I didn't make any losses to him. But even then, consultant is considered a bad personality in contracting, and contractor is considered a bad personality in consultancy. This is directly proportional like this. If you are a contractor, you are considered with different image, and if you are a consultant, you are considered with another image. Oh, you are a consultant. Means after all, goal of both is same. You have to finish product as a contractor, and someone has to supervise your work as a consultant. This is relation, nothing more, nothing less. You are paid to supervise work. You are a consultant or engineer. You are paid to do a job because you are a contractor. You have binding agreement. You have agreement that you have to work, and agreement says the employer shall pay you. And agreement with employer and engineer is that engineer has to supervise work done by contractor, and employer shall pay him. Only this relation is a triangle, but this is not triangle is not integrated. This is separate triangle. In that triangle, there are three corners. One corner goes to employer, other corner goes to contractor. That's one contract, and other corner is combined corner is employer. Other one is engineer. This is management contract or service contract or supervision contract or what you could call that. Doesn't matter, you know. This is a triangle with no direct relation. Engineer is independent person there. Even though engineer is paid by employer, yet its job is to supervise, to superintend, to issue designs and all that. Which work shall be, physically carried out by contractor. This is a simple relation if you understand that. Means one part is engineer, one part is engineer is independent person, you can say, for both, though engineer is bound by agreement with employer, but that agreement only for purpose of commerce, only for purpose of payments or conditions of services, but not binding one. That engineer has to accept whatever employer says, technical or engineering basis. Finance is one part, means service fee is one part, performance is the power. But as far as power is concerned, employer cannot snatch power of engineer, except to an extent it is restrained to budget, restrained to cost of you can say project. So relation is very different. It's just like a doctor treats a patient and doctor takes sound decisions. Of course, patient signs and agrees for operation, but job to be done by doctor is difficult. Signing by patient doesn't mean anything except legal requirement that patient accepted or patient's relatives accepted for this operation and to take all risk post operations. This same thing as here, means employer is just a party to finance contractor as well as to finance employer, and to take responsibility of project in all respects of its investment as well as its profits or losses during its use. And nowadays there's one more which you call third party. In the third party, always these are of course two parties here, two parties in two contracts, but there's another party which is different, which has different contract with employer, and that party is called third party. Third party, or you can say a kind of audit party, audit expert party. That party is completely independent, nothing to do with employer and nothing to do with contractor and nothing to do with engineer. That party, though people are not very clear about that common people, but that party exists these days generally all over the world. It's like like ISO 9001 standardization party or agency, and they are authorized agents. A kind of independent, completely independent party is appointed by employer according to conditions or contract. Employer pays that party, but employer and that party has also different relations. That party takes money, charges from employer, but does work according to contract. That it has to make sure whatever contract is available between employer and contractor, and whatever engineer does, all these officials and organizations must work according to contracts, according to contract documents, and according to contract existing between employer and third party, or according to contract existing between employer and engineer, and also between employer and contractor in whatever capacity. It could be construction contract or it could be EPC. This party's responsibility is not dedicated one. This party's responsibilities like visits and random surveys on this contract performance, which is very important part of current engineering and current requirements. If this party's responsibility is that it has to know everything about contract, it has to know everything about drawings, about specifications, and about requirements. It has, it knows everything. It knows all happenings, all update circulars, all update on instructions. It must know, but it's not bound by those. It has to make sure that contract moves according to documents. That is most important point. If it discovers some lapses on part of contractor or on part of engineer, it is its duty to bring to their notice and recommend corrective actions. It has to direct and suggest everybody what should be done, what should not be done. It has to inspect sites to make sure that work is done according to requirements, according to specifications, quality is maintained, quantity is maintained, progress is maintained, contract doesn't fall in, not all time, visit wise. Scope of it also is written, but it has another scope also, that whatever scope be given, according to third party, it has certain additional responsibility of something like the safety, quality, quantity, everything, even if it's not mentioned, because safety is very important concern which is responsibility of each and everybody. I have seen during my inspections that people are not that serious. They just want to move, even though their tires are punctured. That's a problem. Tendency of contractor, even if they are very high top class contractors playing in billions, they don't respect quality. Engineers to try to hide these quality or defects. Unfortunately, it is job of engineer and his staff is to check everything, but because they may be employed by government, they don't. They want their job safe. They want their job safe. They don't want challenges to job. And I don't know reason why are they not interested in quality. Why are they not interested in defects discovery? I have seen this, but I don't want to. I will criticize them because they may be having some problems. It happens that they might have worked with government before, and post retirement they are given this kind of job, independent job, or you can say contract jobs to supervise. Well, I'm not interested in whatever top jobs they have, but question arises: are they able to work to mark? That's the point here. If you, as engineer, cannot think, if you cannot do, you just want progress only, even though defects are there, you are not able to surveillance jobs and find errors. I think purpose of engineering and engineers is defeated. It's same thing if you employ engineers to supervise or surveillance, or you don't employ, it's same thing. I don't understand reasons behind that, particularly in our country. I'm not finding quality of works to mark, even though it may be very high profile company or it may be very low profile company. It applies to both, and full range of high profile to low profile, whatever sort of companies exist there. I cannot say, it cannot be said that it's okay. I mean, I cannot say it is okay because it's not okay. That's what I can say. Not okay means not okay. Engineer who goes on audit must be very neutral, must be clear about what it is required to do. Engineer TPC cannot favor either one. It could be project engineer on behalf of client or owner, or it would be contractor, site agent, or project manager. Both are equal to that TPC. This is basic principle of TPC. You cannot think even that I have to press contractor and not to press engineer, because for you both are same. Job of contractor is to do job and deliver according to contract requirement, and job of Engineer is on behalf of employer to do all kinds of audits, supervisions, approvals, rejections, and whatever contract applications, contract requirements, demand that is to be done. It is very difficult sometimes to blame someone. It is tendency that we blame contracting organization for everything, though many times contractor organization is okay, others are not okay. That is also true. But it's what you cannot go into depth of every problem. You have to understand whether or not works are according to contract, according to specification. Maybe in 1 month you go once to site, but informations keep on coming to you regularly. So you have to decide where there can be error. You see, most important point on contracts always remain time. Time, which is very important factor, because if there is a delay, that delay is not acceptable. Nobody accepts that delay. Why should someone accept delay? Because it's cost factor. Because contracts delay means liquidated damages can be imposed. Because it impacts on operation or use of project. That's point here. Otherwise, there are defects, of course, workmanship defect or human error defects, those are acceptable provided this can be repaired. These can be repaired. But there are certain defects which cannot even be repaired. Those defects are questionable. For example, I find generally it may be very big project, mega project. You will find occurrence of honeycombing, porosity on concrete, rough surface on concrete, or you can say out of line columns and beams, and you also can say cold joints and uneven surface. Sorry, not diaphragm slabs, your thin slabs. You may say of course it's diaphragm, horizontal diaphragm. And you may say thin slabs. And sometimes even curing is not done properly. And I have noticed sometimes people just try to hide by keeping some adhesion on that portion, or they just repair it by using cement mortar. I have seen this, and sometimes I feel this, why do people do like this? Means repairs are done on sites. Defects are expected. Nobody denies that fact. Defects are expected. It is human that works on sites. Everything cannot be perfect. You are getting thousands of batches or batches of concrete, and uniformity does not exist in all. You will not find same composition exactly in each batch. One batch can differ to some extent by other batch, and there can be some unequal gap between batches, which sometimes people forget to vibrate in time, or they can wait, okay, let another batch comes and will vibrate. It is due to negligence of supervisors and negligence of those who operate. And when your crew gets, and they sweat out, so this generally, don't mind that. But if even if defects happen, just like in safety, ignorance happens. People ignore, neglect requirements, and that state leads to certain kinds of accidents. Though theory is there, everybody says it's a responsibility of everyone, that safety is a responsibility of everyone. But is it? My point is that. Even if somebody neglects, what can you do? Right? So there is responsibility fixed for everybody. There is safety officer or safety engineer. Same way there's a responsibility in construction. There's engineer, there's supervisors, there are contractors agents, contract supervisors. But when it is long project, long duration project, every day you have to do something, and for months and years together, concreting elements goes on. So people become used to that kind of environment. Oh, this is daily routine. We'll take care of this, no problem. We'll take care of honeycombing, we'll take care of cracks, we'll take care of out of line. This thinking comes into minds, and that's very dangerous. This question is very important, means then how to solve this? Point is that, how to solve it? Means one part is real check, real work, real coordination, real information. Other part is just formality. I have even noticed, I observed in my life, quality inspectors, we call them quality engineer or whatever, QC, people used to call QC, quality control. You think are they serious? I have seen many of them not even belonging to engineering profession, from some other field, science field. Well, I don't accept that. You are going to check quality on engineering work. You cannot assign that work to non-engineering professional. But they think differently. Quality person is more responsible, to be very frank, than construction person. Construction person are generally expected to be laymen. Those in field, foreman, general foreman, or below foreman sergeant, like those frontline warriors, they are not very well trained. They are trained only by experience. They don't understand theories. They don't understand criteria. What they understand is that they can do job. That point is very much important too. So there is a person who is from quality and also a person who is engineer on site. Both are, site person has to produce work and quality person has to make sure that whatever work is done according to contract requirement, according to specifications, and according to good practice in engineering. Both have to cooperate with each other. But what happens? Quality person starts thinking that I am above this person and my job is just to check. Just like safety guy thinks that my job is first. They say safety first and they try to think safety is first in organization. This kind of misunderstanding comes in. Safety first doesn't mean you are number one. It means that your responsibility is number one. That's it. You have to make sure everything is safe before doing that. That's the purpose of safety. Quality is also same thing. You have to make sure that everything is done according to requirement. If something is done, you have to tell them how to do it, or you have to cooperate with them. But just say I am coming, you give me paper, I'll come and check, and that's my duty and that's over. This means you don't know profession. You're not a professional. Don't forget, everybody works for concrete or for other items. For project, you can say you are working on project. You are responsible as quality person, and that site person is responsible for doing, and everybody is responsible for their role onto that project. If you say quality is altogether exclusive, I don't agree with that. Quality is very much inclusive part of works, and that you cannot expect that site persons, site people shall take care of quality to an extent you think. because they forget quality while they are under pressure. They forget everything, and that's only purpose. Even site engineers, they know everything, I cannot say, but under pressure they least bother, and they expect that quality guy would take care of this or inform us where there's lapse. So my point of contention is that project doesn't belong to one, it belongs to all. When you are on project, everybody has collective responsibility. I have seen some cases of young quality engineers who do not understand procedures, who have just egoistic nature. I am quality, it's not my job, you do it, I'll come and check. That is, everything cannot be defined on papers. Detailed job roles cannot be defined. Professional has to take responsibility, whether you are a quality professional or a site professional or you are a safety professional or whatever you are. Quality does not identify who you are. Quality identifies only that I have been done. Remember, concrete is very important material everywhere all over the world, and beauty of concrete is it is very easy to do it. It is very easy to do formwork. It's very easy to do steel placement, and it is very easy to do all inserts as well as pouring concrete. This field of scope, this scope in this field of engineering construction is very, very easy in a sense that you can do concrete work, structural concrete work. Doing is not very risky, provided safety is kept intact. But if you do it wrong, if you take it wrong against quality, for example, you miss vibrations, or you can say compaction, you place steel incorrectly, or your concrete mix is not mixed properly, or there is some error, temperature is not maintained. You can do concrete and you do it. Doing its setting and its hardening, that's fine. It's automatic, it's by self action of concrete. You have to do nothing in that except application of vibrator and doing finishing touch. After that, this is not your baby. After that, it takes its own path and sets and hardens. But if it's not done correctly, it's not done according to specifications, and there are probable defects, so its solution is very, very difficult. Suppose it doesn't have required strength due to whatever reason, due to improper mix or lack of curing, or you can say all mixes are very different, not nearly uniform. There are cold joints. You may say whatever. Solution is not feasible. Your concrete is there, but it's not according to acceptance or defined criteria. This means this is defective concrete. This is below standards. And you cannot accept this. What solution? There is no way to amend it. If curing has been missed, curing has missed, what is solution? You can't cure it at a later stage. If there is lack of strength is not accepted, you are not getting minimum strength it should have. What solution? If there is some sagging due to shuttering or due to some other reason, whatever can be done, workmanship is questionable. What can you do? That's the reason, brick wall, if not done correctly can be removed and redone. Your finishes can be redone. All other items which are not going to take any load, any stresses, but adding their own weight to structure, those can be replaced. Doors and windows can be replaced. Means structure cannot be replaced. That is main aspect we should be worried about. Structure is very dangerous word if you take it negatively, and is very strong word if you take it positively. Structure means something different. This means you have produced very long living entity, very long living entity in this world in form of RCC or pre-stressed concrete, which is a kind of self-manufacturing in yard or on site. Structure is like, once it is done, you have no control on this. From foundations are all upper stories, all complete structure, which has its own functioning, its own style of survival, and its own style of distressing, its own style of yielding, and its own style of collapsing, if it ever does. Just like you can't help soil, it's natural, you can't help structure also once it is done. So it's a big question mark. And only solution, or you can say preventive measure, is protective measure, is like fire suppression or fire prevention. We say loss prevention or fire suppression. When your structure is on fire and you did not make any provision of loss prevention, certainly you shall have to suppress fire, extinguish fire. But if you thought of that before doing structure in designs, what precautionary measures can be taken so that this structure resists fire for as much longer duration as is possible, 30 minutes, 60 minutes, 2 hours, whatever, because you cannot say structure is fireproof or even structure is seismic proof. Yeah, resistance is applicable, that this is fire resistance for so many minutes, or this is shock resistant, or seismic resistant for so much acceleration, or this is, you can say, blast resistance or blast resilient or non-blast. You see, quality works everywhere. I'm not worried about bricks because I'm not worried about stones. As an engineer or as a human being, if my body pains, I feel it. If my parts of body pains, I feel it. I go to doctor, do x-rays, tests, everything, we do it. There is a way out. You can get treatment. You can get physiotherapy. You can be operated. But structure has a different world. It is very artistic to create it, but you don't feel what's happening within the structure. You can only observe and understand how it is conducting. It cannot tell you, only its stage can tell you. Your experience can understand what it's saying. Therefore, we have no solution. We may apply our own understanding based solutions, that may work, that may not work. Therefore, what I say, quality in structures is having extensive or widest definition, but not real definition. Generally, you have seen in many private buildings and other buildings all over, in this country. I cannot say about others because I have not seen all countries. In African countries, other countries, it's known that similar defects happen, and walls display cracks, inclined cracks on superstructure portion, and it happens. And people say this is equal or unequal settlement, whatever reason they say. But why? Why unequal settlement? Point stands, why unequal settlement? And it's really very appreciative that we should understand that. And if we cannot understand that, what for we are there? What is purpose of engineering? What's purpose of using mind? What's purpose of thinking? Thinking means engineering. If you cannot think, forget you are engineer. You are not a crammer. You are not a writer. Engineering means thinking. And thinking is, you can say, root of engineering. It is only profession where mind is applied directly. Nobody tells you what to do. You have to think yourself. Yes, there are formula, there are definitions, there are theories, everything is there. But you have to decide. You have to think before doing something, right or wrong, whether you are moving on a path which is rightly leading you or you are misled. Forget your what you learned in university. That was very childish stage, baby engineer stage. But when you are going to have your own independent responsibility, then your mind is so sharp. Engineering makes you so sharp in thinking. Analysis is your hobby. Analysis is your toy, like a child plays with toys. Engineer's toy is analysis. Engineer's toy is detailed calculations. Engineer's toy is getting more and more alternatives. And if you cannot get those, you can't call yourself engineer. I'm not talking about engineer title, I'm talking about engineer conduct. If you don't value quality, you value only quantity, then you are not at all engineer. Because when you say quantity, product, what I understand and what you have to understand, product means quantity and quality. If it is quality less product, it's a scrap, it's no meaning. You might have spent lot of money on that, but because intended purpose is not served. So what's meaning of that product? It's like vegetable, rotten one, throw it. If you speak like that, people may name you something else. No problem. Name, but facts cannot be hidden, facts cannot be denied. Generally, I have seen quality misses everywhere. Everywhere. Yes, products are being used, projects are used, they are operating, but if you look at them very closely, you will find that no work is to mark. You may have seen, for example, reinforcing steel everywhere, maybe big project or small project. You will find that it's all rusted. Rusted steel. And nobody is serious. Nobody is even looking at that. Why? You ask some person, you go to some site, you see steel bars are lying in open and moisture corrodes them, rain corrodes them. Sometimes they are directly on ground, touching soil. There's no proper base for storing steel. There's no proper arrangement to protect steel from being impacted upon by moisture and leading to corrosion. Nobody cares about. Every qualified engineer is available. ME, PhD, and I think all, but nobody bothers. And they use it in works. I have seen many projects. Even metro is not away from that. They use it. Nobody questions. What does it mean? You are accepting disease right? Is rust not a disease? Is dirty sand not a disease? Are dirty aggregates not a disease? Is partly cement not a disease? Is non-construction water not a disease? My points are quality involves everything, and all these materials which are required to be added to your permanent inclusion items must be properly used. You are not caring about cold joints in concrete, and these are clearly visible later on that you produce cold joints. Particularly at that joint, you will not find component of concrete to be same as it should be. Cold set concrete is harmful because reaction is already over. Reaction is already over, chemical reaction, and you are adding, you can say where already chemical reaction is finished, that is called old concrete, and you did not compact that or vibrate that before doing new concrete. So these types of defect do happen due to various reasons of ignorance or carelessness or maybe lack of knowledge. Good morning, Mr. Pramod Kumar. You're welcome. So I can say when I talk of quality, it has many aspects, many elevations, many sections, many plans. Each one must be considered on its own. There is no general blanket statement we can give. It depends upon many factors. And even if you are getting concrete from a batching plant, you cannot say that you are risk free. You can't say that. I got from batching plant, so I am risk free. You can't say that. It's your responsibility as an engineer to direct batching plant or to make sure what batching plant is doing. Whether batching plant conducted trials on that or it's just giving because of its own designs, and what it's testing there in plant itself. We have to, means what doc says doesn't matter. Document says something. But did you note that? Did you visit that? Did you inspect that? Calibration is okay or not okay? How it's working? Everything must be checked. And when this concrete is delivered to site, what is site inspection? What is, immediately you inspect? You may say, I have taken slum. Alright, you have taken slum. Did you understand temperature? Did you take temperature of concrete related to temperature of environment? Everything must be, how many minutes did it take from batching plant to your site? And what's maximum time allowed? Generally, many hours sometimes, half an hour sometime, 2 hours sometime, depending on what type of cementing material you are using. There may be cases that sometimes GGBS is used, sometimes PFA is used, sometimes microcycla is used. No. Every case is different. PFA is not that powerful as GGBS is. I know you know PFA, pulverized fuel ash. If you use this in replacement of cement, it's better, but much better is GGBS. If you use that, because that can be ground further. PFA is having some restrictions on its fineness, while GGBS can be more ground, much more better than what PFA can do. And then if you go on mounting scale, you can see silica fumes or you can say microsilica, which is higher in value, which is higher in its use than PFA and GGBS. So all these points must be taken care of. Which concrete you are using. I ask people when somebody comes, means what are you using? I say OPC. Why are you using OPC? They have no answer. I ask one quality person on project, means what concrete, what cement you are using? I says OPC. How OPC? Show me. Oh no, it is having PFA content also. What percentage of PFA it's having is 25%. Why are you using PFA? Why don't you do GGBS? First of all, it does not understand what GGBS is. And if it's, oh no, GGBS is not available. Well, it's a question of thousands of cubic meter concrete in these projects, and you are saying without any investigation, without an inquiry, that it's not available. What does it mean? It means you think it's not available for you, you're having a big project. Why you are in PFA? What's the reason you are in PFA? You may say that we are going to use pozzolanic material, which can increase setting time to some extent, and it can act like low shrinkage concrete. Well, that's acceptable, that's fine. But question is, then don't say OPC in that case, means it's not OPC. Means people are not clear about concrete technology, and concrete is a technology these days. It's not simply a material. You cannot say concrete is a material. It's very big technology and it impacts on everything. As I said, it's easy to cast concrete, it's easy to do concrete practically, but once it is done, it's beyond your control. It goes beyond your control. Nobody has any control on that. That's very much true. So my part is, quality is not in spelling nowadays. Quality is not spelling, it's a word. If you say, I have done this work to so many units, this means quality factor is included in that. That's understood. Material that you get, product that you get, it must be qualitatively and qualitatively delivered. Common people do not have any idea of quality. For them, old style, it still works. You go and see any building, whatever building, you will find same old style. People do not understand anything about that. You can see they just excavate, do same old style footings, columns, later on they do, and walls they start before everything else. And for them, it is conventional work. They don't understand anything about rigidity of that. They erase brick walls first and then put column in between, and then all walls finished, and then they start working on slab. For them, they think it's stronger than something else. It's their understanding. I can't say. In fact, they spoil framework. Some people use even columns which can't be defined. Columns means you can say it's a 9 inches, that's 225 mm into 225, or 9 inches by 9 inches. Columns, they say, which can't be called columns in short term columns, shorts length column, can't call them columns, because 12 times it should be least minimum dimensions. So 225 it is, I mean to say 9 inches, and if you multiply by 12, 12 into 9, 108, which is 9 feet. You don't go beyond 9 feet, but minimum dimension of a column should be 1 feet, 30 centimeter, 300 mm. That's requirement. But for them, there is nothing as such. Means okay, we do column. Yeah, you can accept these columns, the bonding columns for walls. That's acceptable. That we use them as walls column, means where bonding is required. And bonding means vertical columns you add and horizontal beam you have. It can be called bonded wall. That's okay. But you can't say it's a structure. But people don't understand anything. They insert column later. First they do wall. They want to avoid shutting, and they increase bond between column surface and walls, which increases rigidity rather than leaving flexible. So means building becomes rigid, more rigid than flexible, which is against horizontal actions that are imported during seismic actions or wind actions. And building acts as rigid one, not flexible one, and it dampens vibrations lesser than it should have. So it is against its own conduct, but people don't have that level of clarity, and even some engineers don't have that level of clarity. That's why I'm saying this world of structure is very complex, easy to do, but difficult to control. It's beyond our control. In everything you can see this is a disclaimer that it's beyond our control, but you can't use even disclaimer because you're a designer or you're an engineer. It's your duty to make sure everything is fun. That's why I say engineering is lost in field, and is lost in field and lost in such a way. Even if somebody points out, people laugh, start laughing. Means, we are not practical. You are talking theory. You are talking this and that. And I face all such issues number of times. People comment like that, and I have been overseas for many years, and I have learnt there a lot from viewpoint of field, not from, you can say, theory of structure viewpoint or designs viewpoint. You have to learn something from field, and when you learn something from field, you shall certainly find defects in field, and those defects, if you know what problem side people face while doing works, those, when you work in design, must know what sort of problems do appear, and you take those factors into your consideration while designing and detailing. I think you can do better design. Now, as I said, I explained about corrosion or rusted steel, which is very important part of RCC. Means, why do we accept that? It should not be accepted. No factory delivers you rusted steel. It's due to your carelessness, your ignorance, or you can say you don't understand facts. Use this steel. Means, if you are happy to use rust and you think it's very stronger, then I can't define your mind. I can't blame your mind also, because you have not studied well. And I have seen even somebody say, oh, loose one is not acceptable, but hard one is acceptable also. Well, I laugh on that. Means, how can you say rust is acceptable? Rust can never be acceptable on steel. If rust is acceptable, then better take all rusted steel, rust it forever, keep there for 6 months or 1 year on ground, and let it be rusted properly. It's laughing stock completely. If you are not intelligent, what can I do? If you are happy with rusted, better take epoxy coated steel and use it. Or you blast it and use it. Means, how can you permit rust? Means, we just pass engineering and that's it. Application is not passed, theory is passed. When you come out of university, you passed only theory. You did not pass applications. And engineering is application, not theory. In practical world, application is important. Without application, you cannot do anything. There is lot of theory, books of theory of structure, applied mechanics, theory of structures. You have to do a lot. You studied theory for 2 years probably out of 4 years. But that theory, mason doesn't know, carpenter doesn't know, supervisor doesn't know, foreman doesn't know. Who knows? You know. But where it is used on site, tell me. No, it's not used on site. On site, application is used, but you are not clear application. That's the point where quality comes in. Only purpose is, I'm trying to communicate to you power of loss of quality. Why I say power of loss of quality? Because quality has never been understood correctly. It has been understood only to point of view of workmanship and nothing else. There's a difference between workmanship and quality. Workmanship is superficial, it is dimension, it is straightness, or it is surface finish. But quality is not that. Quality is thorough, it includes workmanship. Workmanship doesn't include quality. Quality includes workmanship, just like, quantity includes quality. Quantity includes quality, means if your quality is not effective, it's not to mark, quantity is rejected. We have to understand all this. And quality is not control alone. It's not alone control. You say quality control? No. Quality control is not quality. That is baby of quality, you can say. That is child of quality. That is one part of quality. Quality is a process. Quality is an organization of your job. Quality is, you can say, world you have to live in. Quality drawing, quality design, quality construction, quality designer, quality engineer, quality supervisor, quality foreman, and quality inspector. Quality inspector. We call quality inspector or quality check. Why? Because that person should be different. We call foreman, okay, he knows nothing, he's a layman. Same thing, call a charge hand, we call a site other person, or even site engineers are sometimes called layman engineers. Because don't care about everything, they just want to move fast, achieve progress, says I have achieved this milestone of progress. Not more than that. But a person whose title is quality itself, that person must be different. If that person is not different, who's different? Tell me. Name itself is quality, means you should be a person of quality. You should know technology. You should understand how to apply that. And you have to instruct us what to do, what not to do. If other guys making mistake, point out, tell you are doing mistake. But that, you think your job is only go and see and come back. No, it's not. It's not. Quality work it should be. It should be quality work, but it is not. That's where I stand differently with others' opinion, and I have difference of opinion with many people. If you just keep yourself, it's not my responsibility, then whose responsibility is this? You are there on site, in office, you're designing. While designing, you should know what problem can you face or can those working on site face from designs. Means your design, whatever design you do, whatever detailing you do, should be as easy as possible, as easy to understand as possible, as easy to be worked on or carried out possible. It should be so easy that comfortably construction is done. Or you can say construction ability is easier. And if you make design so complicated that people are not clear about, only you be clear about, then you cannot say you have done service to that project. Sometimes, people do not like very complicated detailing. They want easy detailing, comfortable detailing, and comfortable detailing is actually very difficult. Just like we say simplified design is very difficult and very complicated design happens. When you say simple design, doesn't mean easy one. It means you have to think a lot on that before designing. You have to think a lot before you are doing something on site. And in general, we can say certain statements, we call them method statements. Method statements are very important part of construction and of engineering. Method statement means we have to be clear about what we are going to do. That's very important part. What we have to do, that part is very important. Means we cannot simply say, we cannot simply isolate ourselves from real responsibility, because method we have to devise. Method we have to devise. What do we want to achieve? What do we want not to achieve? What quality level we want to achieve? Each stage of work we have to define. Method statement is a technical work. It's not a formality. When you say, I don't have any method how to do this, this means method statement is not available. Why it's not available? I cannot answer. Only person who is working on site that can answer. Either method exists in minds of engineers. If it exists only in minds of engineers, but minds cannot communicate to those on site. People on site, they cannot come to you all time, every time, each time, for every activity to tell you what to do. And I think you have not instructed them and you instruct only points, then come back, it doesn't work. Now, world is different. Means every activity you do on site, every activity, it should be defined in, you can say, precise way. It should be defined clearly and precisely. No point should be missed out. I usually say, actually not usually say, it is it is responsibility, it's obligation that methods should be clearly written and approved before work is done. Method means what you are going to do on project activity from A to Z. How you are going to do setting out of site, how you are going to do pre-excavation work, how we are going to go to excavation work, blinding work, waterproofing work, foundation work, form work, steel work, or whatever is required. You have to write each activity definition, what scope it is, what material is used, and you can say what equipment are required, what sort of people are required, what is reference of this work, and why and how you shall do this. Means it is your role. Means when you are going to do it without any explanation, without any record, others, that you can, there's a difference or there's a flaw in communication. What you explain to them, some explanation goes in here, and maybe 25 to 50% is received by other party, other people. This means you cannot explain to them, they fail to explain to them. So only alternative is you write method statement for that item, and if you have power to approve it, or if somebody other has power to approve it, and then you give to your people, explain to them this is required, and if you have to make some sketch with that, explain to points what material you need, what equipment we need, which is approval material, which is not approved material, and then of course you are there or your supervisor is there on site. So you have to, once you agree on that material, your engineer agrees on that material, not material, a method statement. That is a statement in writing, but that statement should be done on site. That is beauty of work. If you have this practice, I think there are chances that very few mistakes happen. Generally there should be no, because you are going to follow method statement, and particularly in structure I say it should be. Just like we make working drawings, we make shop drawings for purposes of detailed clarification, even in we make some, I've seen even people do a lot of drawing work for site purpose, and that's really appreciable. Means when you do such drawing work, you will certainly think of, even if you don't think of, these activities which disclose themselves, where I'm clashing with this one. That's important. You can say it's a part of communication coordination between various disciplines, various subdisciplines, and communication, how to communicate. So method state is one communication, just like we write letters and memos and all that, or we make drawings, or we make sketches. It's a kind of declaration, we are going to do this, and we have to do that way. So when you write something like that, you will refer to drawings, you refer to specifications, you shall certainly refer to whatever relevant details, and only then you can write. You shall write your references also on that. This is reference, that is reference, and you may attach that also if it's a required method statement, so that it's ready available for everybody who is involved with that, consultant, engineer, yourself, your staff, and all this. I don't know how many people understand this point, how many people are using this, but I used to write many statements my career and for every project, and it's sometimes very interesting because you whatever activity you write on, you become clear about that. You extract all references which are going to apply that, and you say this is reference, that is reference, this is material approved for this is drawing approved for this. All are packed up, all are clubbed in, and that's, you say how we are going to do that. At this stage we do number 1, number 2, number 3, like that. And where inspections are going to be conducted by quality people and by consultants and by your people, where shall you inspect, where shall you check, where shall quality guy check, where shall constant check, all that. That shall be completely done. What materials you use, and if you are going to say concrete work, how shall you do it? You may have to make some plan of that. Means there's a big, massive concrete, then because cold joint is to be avoided, and what method you're going to stepping in that, or you're going to do some other way, layers only. It depends on timings. It depends on rotation of concrete, because concrete comes in big quantity, in 9 cubic meters, say it comes, a truck comes in, and you have to vacate, you empty it within 5 minutes, and later on another one's waiting for that. It depends, means what's also column only where very slow concrete goes on. It depends. So everything you have to understand. You know by your experience how much time it take, and you accordingly make that sketch. Where shall you plant? Where shall you station your pump? Where shall you station your transfer mixer for unloading? Where shall you stay your means whatever access ingress or egress from deep pit or from of a superstructure? How you do that? All these method statements very important part. It is more, I think, more important from quality aspect. If you want to achieve quality, you should know what you're going to do, and what you're going to do is very important. This you know in beginning. What shall you do? Everybody who reads that statement shall know what to do. What to do means how much you will write in that also, how much quantity of concrete shall be consumed, how much steel is there, and how many trucks of concrete. And because practically speaking, you have to take some margin in terms of steel quantity, and you can't say just by volume I order. Yes, you can order by volume, but at end of that concrete you can say, hold on please, hold on last 2 trucks, and we'll tell you how shall this come, because a few cubic meter of concrete is to be adjusted, that because of concrete steel volume. So what I'm saying is, certain work about that, you take into your consideration a method statement, also steel placing, and also this cathodic protection or some other kind of protection or some other kind of work, or is epoxy coated steel, or it's something else, or what sort of concrete you are going to do, microsilica replacement, or you can say GGBS replacement, or what you do, temperature controls, differential thermometer you place in for temperature gradient, thermal gradient, the mass concrete, or some other way, it's isolate footing or strip beam or raft, is also a heavy structure. It means you know what to do, and this only not concrete but also for other non-concrete items like brick work, brick wall, flooring, whatever work you do. Means method statement is such a system. Maybe in building work or normal building work, you have to write 100 method statements or 50 method statements, depending on what structure I'm talking of is very much important. Because other items can be replaced, but structure cannot be replaced once you do it. Foundations to top, and also not only this, foundation may have to write method statements. For example, I said you write about surveying, you can say method statement. You can write about excavation, method statement. You can write about, you may say about foundations, or you can say about form work, about steel fixing, and you can say about everything, column work, beam work, suspended slab, total work, structural metals, cutting and bending, how you want to cut and bend, how you want to protection of steel, or compaction of formation. Likewise, it depends on you, means how best you want to do work. Once you have a habit of writing method statements, and people have a habit to refer to them, means I don't say you just stand with that side, copy or explain to them. And when you explain to them, to your foreman, sergeant, supervisor, or junior, I think they will keep, and they'll always demand if there is a method statement because that. So you have to make that in advance. I say that method statement is a part of quality structure of project. Generally, it should be done by quality people, or if not done by quality people, it should be done by those directly involved in construction, like project manager. It must be reviewed by quality person. Review doesn't mean examination. Review means they should know what you are going to do, And if they think, no, this is not right, you should do this way, then you can modify that. But they would know what's going to happen. That's the beauty of method statement. They write everything. We are ready for this work. And before method statement, this is for every activity. You can also repeat those statements as well. When this is statement general for slab, this is statement general for columns, this statement general for foundations, or whatever item you talk of, you take into your consideration. If certainly when you do method statement, you will say this quantity of concrete, this quantity of this quantity of that, and because this is quantity of concrete and our batching plant is giving 35 cubic meter or 40 cubic meter per hour or 50 cubic meter per hour, or there are 2 or 3 batching plants there, mixers there, so how much concrete you can get from working mixers, not from standby, and how many hours it will take. You can define time, means every 10 minutes you have to send this transfer mixer, or every 15 minutes you have to send this transfer mixer, or every 5 minutes you have to send. Depends on how speedily you can pour this mass concretes or massive blocks, or how slow you are on that. So that empirical guidance, that real guidance required by site people is already with you, and you too shall also be guided, because you also forget. You're too busy there. So when you devise this document, shall guide you what you are going to do. What I'm saying is that all we are discussing part of quality. Part of quality, we are not interested in quantity, was quantity integrated with quality, that is called quantity. If you can't integrate that, then I have no comment on that. That's why I'm stressing engineering community, particularly those engineers coming out fresh and those who are in budding stages and those who are advancing, uh, uh, and those I think who have worked overseas, in particularly in Gulf countries, and they should know how was the standard one was best. So when you say quality work, means all this should be done. It's not only this. So for example, I'm giving the example of rust and just comes concrete, steel. People don't understand how to product it. Means they say how it's the natural. No, it's not natural. It's very easy to take care of that. Only common sense says when you get steel, first of all, it should be placed on a better platform. It should be free from soil touch. Your steel should not touch soil, and it should be placed on some temporary platform, made of timber or made of block or made of bricks or whatever. Water from ground should not go into surface of steel, and also water from air should not go, moisture from air should not go to touch steel, and you have to protect that. And how can you protect? It's very easy to answer that. Of course, you are not going to make a room for that. Just means you have to use certain wrapping plastic, cover it, cover steel stack with the plastic, and keep so that moisture doesn't enter. Just like moisture cannot enter a steam store, but still they know it. But go and see cement stores, you will find you know entry of air everywhere. While it should be airtight, it's not. So that's what I'm saying. Means to say, quality is no dimension. It has all dimension, all directions, and that's why quality is very important part. And my talk is about quality, and I have talked about quality system, that is ISO 9001. This is AnnexSL. I talked the basics of that in last videos. Then you know, I talked about construction system, RCC construction system, the buildings. And now later on, I was talking about this, which is on project now, which on screen you can say this is quality system, supervising management, RCC buildings, construction, template. And I have gone through this last time, many pages of this, and it is here. You can say, I think I have gone through its scope. I think this is supervising. Then we can say clause 4, that was and clause 7, which is support, I am sure. Support, and clause 8 is clause 8. Leadership. Leadership we have seen in this, and we have gone through various points of leadership in which you think actually planning it was leadership is before that. We have to say planning, what we did in planning here. You know, it says action to address risks and opportunities, management system objectives, and planning to achieve those objectives. Then points for considerations were being risk based thinking to front, bring it's not being, bring, it is bring risk based thinking to front. uh, Once organization pinpoint points risk and opportunities, it has to work out how to resolve address through planning what, who, how, and when these risks be addressed, just like plan, do, check, and pro. Plan, do, check, act, we say PDCA. So what, who, how, and when these risks be addressed. This approach replaces preventive action and reduce risk of a corrective action. Objectives of management system should be measurable, communicated, aligned to management system policy, and updated as and when required. In this we can say what points can be considered. Risk in supervising management contracting, not easy, risk versus is not clearly located. You mean say how can start site some lack of information. So these are points. I'm just giving a reference only. Site is located, but some issues exist for giving its clearance so that it may not be handed over. It may not be handed over to contractor successfully, either in part or in full. Site is running underneath with many live services which require detailed investigation and later either relocation or diversion of those services. It could happen this. You cannot break services. That's not beyond your, that's out of your power. So it says site is running underneath with many live services probably that requires a detailed investigation and later either relocation or diversion, and maybe information required from client is not available in time, which can contribute waste potential work hours. And then site surveys are not conducted in time. Site surveys are not conducted in time due to non-availability of site exploration agency, vendor. This could be there. You have to conduct site surveys, and that site surveys can be conducted only by surveying laboratories, or you can say material testing laboratory. Generally, they conduct surveys. So sites or surveying companies may be there who conduct geographical and geotechnical surveys, or if required biothermic surveys. uh, Site surveys are not conducted in time due to non-availability of site exploration agency, vendor. Site soil exploration is not carried out in time according to schedule due to non-availability of site exploration agent, vendor, and architect delays issue of record drawings, which could be a possibility. Required drawings, subcontractors and proposals are not submitted by contractor in scheduled time, and curriculum vitae related to key persons are not proposed by contractor for approval for schedule, and services engineers delay issues related to allied drawings, work supervising management service, subcontract payment are not released in the scheduled time from client, material submissions are delayed by contractor, shop and working drawings submissions are delayed by contractor, contractor delays on submission of method statements required to be approved by supervising management team, I can say site safety operations are not conducted adequately, all foregoing issues can be checked by intensive engineering coordination from one inception of award of service contract. Every leader responsible for task should follow progress by all interactive persons all times and status updated. Issues should be raised in internal as well as in external meetings with all others involved. All minutes of meetings should be recorded and communicated to involved person formally, later on giving reminders and further follow-up of related activity update. In fact, an excellently performing coordinating engineer or manager shall be required to be appointed by both contractor and supervising agency so that regular review of contract requirements and follow-up of resolutions may be made whenever be necessary. So in these points, very few points are there. We have considered something we can say, just like we say risk factors we have considered what technically risk can come in, not legally or commercial risk. It is not, you know, for example, we talked of coordinates here, coordinates issue, and then we talked of sites not handed over to contractor in time due to whatever reasons. Then services run underneath record drawings we need for that means live services we have to hold the work and see how to handle them. Then information is absent from client, which is also very important point. Site service not done in time, agency is not available, site exploration is also not done in time. Survey and site exploration both are here. Soil exploration survey is okay, fine, can be done, but exploration is also very important, which is a part of design, how design has been done if there's no exploration. And you can see then architect delay some drawings, then subcontractor proposals not submitted in time, subcontractor proposal many means material proposal drawings, some proposals and like that. CVs are not approved in time due to whatever reasons, and all allied drawings which service engineers are required to submit for work, these are not available. Then payments are not available, so material submissions and drawing submittals, working drawings, shop drawings and method statements included. Then site safety issues are in written writing means these are not done properly. Then you can say there's no person to look after all this. That can also be a point, means even if contractor wants to do that, but there's no one to lead those activities. Everyone is responsible for tasks should follow process of interactive persons all times. There's coordination, then meetings, record and actions. So you can say at the end that excellently performing coordinating engineer or manager must be required to be appointed by both contractor and supervising agency so that regular review of contract requirements and contract movement, which are not written here, contract move, progress or follow-up for resolutions may be made whenever be necessary. So what I say means there are miscellaneous issues on construction activities, and every activity is important. To be frank, every activity is important. I cannot say only structure is important, every activity is important, particularly structural related activity. As I say, point about surveying, geological survey or geotechnical survey, which are very important for mega projects. Means maybe it's not important for your small building, but for multi-complex building or for refinery, or for you can say oil or plants project, which are having very wider dimensions of plot and many different layers of soil from one place to another place. So geotechnical investigation and geographical investigation are very important factors. Both are different. Geological factor says it is regarding in-depth study of strata, while geographical says that you have to see contour of that area and also what is hidden below, say defined depths of 4 meters or 5 meters, you can say maximum what exists there. So those are very important points. And then soil investigation is a part of soil exploration, is very important one. And it's not in one place you do it, you have to do depending on what is layout of your complex or layout of your building sites on that project. You have to see that those trials might be done much earlier, and now it's taken care of. But I think that's very important point. Soil, we should know, we have complete knowledge of soil that is involved on that project, and that information can come only by conducting soil surveys, which material testing laboratory would support. And of course they won't charge much on this, but they're just to give, yes, I'm weeping or I'm not weeping. So that point is, then we come to support of this in class 7. Support, and what support means, if you see here, we need support of resources, competence, awareness, communication. These are supports. Then documented information. So what are points for consideration in this case? It says material, equipment and human resources. These are supports, of course. You need material, you need equipment, you need human resources, and also now capacity, potential of organization and individuals. What is strength of people? What's legal capacity of potential? I guess the potential capacity of organization and individuals. Qualification of personnel, and awareness among all pertinent system and its functioning. Then which written job description, work procedures, safety procedures, quality control procedures, administration method, etc. Documented information is different than documentation. Whatever information about management and procedures of process in whatever form, such as written text, maps, charts, designs, successful implementation, evidence of compliance of requirements, etc. No system of documents be evidently true. So we come to point of material equipment, human resources, capacity, potential of organization and individual qualification of personal awareness of all pertinent system and its functioning, written job description, work procedures, safety procedures, quality control procedures, administration methods. Documented information is different than documentation. And you can say documented information is different than documentation, and whatever information about management and procedures or process in whatever form, such as written text, maps, charts, design, successful implementation in the way of phase. So point comes in about written job description, work procedures, safety procedures, quality control procedures, administration methods. Documented information is different than documentation. Whatever information about management and procedures be then you can say after that document information is different in documentation. Whatever information about management and procedure of process in whatever form, such as written text, maps, charts, designs, successful implementation, evidence of compliance of requirements, no system of documents, but no system documents, but evidently available documents for reference and for design review. So we should go further now and think of what we have to say in this regard. Now, we have to think differently actually. It's easy to think differently rather than stick to points somewhere, right? Now, resources being electronic equipment, computers, printers, office establishments. Resources being documentary information. You see, these are all resources. Resources being electronic equipment, computers, printers, office establishment. Resources being documentary information. All supervising human resources being leaders, senior engineers, leaders, senior engineers, engineers. All supervising human resources should have relevant professional diplomas or degrees. Leaders and seniors should have required registrations with authorities and institutions as required by law of land. All personnel should have adequate expertise in respective disciplines or calling. All personnel should be inducted with required information, given understanding regarding management systems, its relative risk and reduction of risks. All personnel should communicate for all significant activities, and leaders need ensure working of complete effective coordination. Communication, all information and communication should be recorded properly to demonstrate that system has been adequately complied with. No superfluous work should be carried out if not so required, but essential activity or operational task should not miss. Additionally, outsource supports You may say no superficial work should be carried out if not so required, but essential activity or operational tasks should not miss. And this because all information communication should be recorded properly to demonstrate the system has been adequately complied with. Then, additionally, outsourced support should be used in case required, keeping abreast project requirement. So these are very small. Is given here means let's say again is resources with electronic equipment, computers, printers, office establishment, documentary information, then supervising human resources like senior leaders, seniors and also all supervising human resources should have relevant professional diplomas or degrees, and leaders and seniors should have required registration with authorities and institutions required by law. All persons should have adequate experience in respective disciplines or calling. All personnel should be inducted with required information, given understanding regarding management system, its relative risk and reduction of risks. All personnel should communicate for all significant activities, and leaders need ensure working of complete effective coordination communication. All information and communication should be recorded properly to demonstrate that system has been adequately complied with. No superfluous work should be carried out if not so required. but essential activity in operational tasks should not miss. So no supervised work should be carried out if not so required, but essential activity or operational task should not miss. Additionally, outsource support need of our Additionally, outsource support should be used in case so required, keeping in view project requirements. You know what support I mean to say. There is no limit to support. Everything is support. What is used on site is support. What documents used are support. Materials used are support. Resources used are support. Equipment used are support. And those professionals who run this room are missed. Now we'll go to operation. Operation. Operation means you can say operational planning and control and points of consideration. In-house process, outsourced processes. Overall process management includes adequate criteria to control these processes, manage planned and unintended changes. So operation is one part. Operation is very important dividend. Now we'll say operations. After all, what we say about operation, this is clause 8 is for all annexes operations are here. All operations involved on supervising projects related to RCC buildings amount to numerous activities, varying in nature from structural to non-structural finishes, finishings, claddings, closure of openings, and many others. All such activities require varying procedures. Varying procedures on same location, which are based on varying national and international codes and practices as well as manufacturing instructions. Content should be very effective in understanding, selecting, and proposing all requirements related to each activity assigned. Then we can say all such activities require varying procedures on same locations, which are based on varying national and international codes and practices as well as manufacturers' instructions. Contractors should be very effective in understanding, selecting, and proposing all requirements related to each activity operation. Outsourcing may be effective for certain essentials for which there is some shortage in supervising house management. Then you can say outsourcing may be effective for certain essentials for which there is some shortage in supervising house management. Then leaders require necessarily as part of job description to ensure that all operations do well in all respects, including original supervision, operations following by certification of final product. Leader has to produce schedule showing all dates from commencement of project to stage-wise work deliveries and all completed deliveries, including performance, testing, and commissioning. Whatever changes are required to be incorporated should be affected during all stages. Red lines recorded as built required so as not to delay any task. Once all operations on project are completed, project requires closure to close contract formally according to practice and conventions. Contractor requires to submit complete dossiers in all respects to cover whole documentation of project performance, which would support future references for end user. Supervising manager is responsible to receive all such dossiers for review and final approval of testing. Then you can say all such dossiers for review and final approval and charting procedure of contract so that a completion date is appointed for contract works for successful completion of contract and leading contract to maintenance period, including defects, liability period, and further followed by final completion of contract to discharge contractor. These are, suppose we have gone, to say, kind of operation. Now, operations are enormous, not this or not that. Every work is actually operation on site, and we can just go further study and later on we'll take care of all overall talk. It's now performance evaluation. Performance evaluation. This is very important point. It cannot be taken for granted. It should be taken care of adequately, and that is performance evaluation. Performance evaluation. What do you perform? Its point here. What do you perform? How do you perform? How do you do that? All these come into this. What do you perform? We cannot simply say perform is perform. Perform it, which is basis of, you can say, when I say perform means you can say in this form, in that form, in all directions, in every elevation, what has gone, how did you do that? Very important point, in fact, very, very important point. We don't take care some time, but it is. Just hold on, please. Just a minute, I'll be back. A few seconds. Walking a little. Jam, my leg is jammed. So we are talking of performance, which is very basics and which is answer to every problem. Performance. How do we perform? Performance is not, we cannot explain in talk. Performance is required to be expressed properly. It has to be expressed work-wise. It has to be expressed virtually and physically. We call performance evaluation. It is value of work we have done in its effect. You can say that is monitorable, that is auditable, and that is reviewable. Now, management has to decide about its own audit. It has to make sure that management understands its own value, how far it has gone to abide by requirement. And if there is a lapse, it has to discover that, it has to point out. If it thinks that it's complied, or it's think that partly complied or not complied, how there is a defect, it has to be understood, or it has been complying, means it's okay, where it was suitable, adequately, effectively, and all this is required to be done on its own. As we say, plan, do, check, act. Plan, do, check, act, we always say. So how to explain it? Now, supervising operations are monitorable and measurable for purpose of further analysis and earned evaluation. Supervising operations are monitorable and measurable for purpose of further analysis and earned values. What is earned value? I think you understand that. It's nothing new. Whatever work you have done, that is earned one. Means you have earned that work, value of that work. Monitoring, measurements, monitoring, and you are monitoring and then you are taking measurements as well, means. And analysis and evaluation is defined process, means which requires to be conducted both by internally developed management as well as at defined schedules by external third-party audit authorities. Now, many observations are recorded by both internal and external auditors, which notings and observations and instructions should be entirely reviewed by top management, top leaders. Top leaders then requires to decide degree of compliance of current system and what steps shall be required to be taken to make it fully compliant, and also what degree of value engineering can be inducted onto existing system for further successful completions. Now, this is performance evaluation, which is a part 9, clause 9. Now, it's who shall do it, means management will do it. Your supervisors are there who monitor site, who did everything to abide by contract requirements, to comply those, complied quality, complied quantity, complied specifications. Now, everything has been done, but you cannot say perfection achieved. So you have to understand, you have to monitor, you have to measure up to what degree you have achieved it, up to what degree. That point is very, very important. You can say you have to monitor, you have to measure all achievements, analyze them. Yes, you have to do all that. And there are provisions that you have your own internal team and the quality system, your internal auditors who self-evaluate You then see their reports, means where was error or where was okay, some observation will come to you. And also at frequent intervals you have to call third party observer, or you can say those agencies who are responsible for your certification of quality system ISO 9001 or else. Those would come and observe all at random or whatever way, and you have to then assess yourself based on your internal input as well as external input. There would be observations, there would be many more aspects, suggestions as well, recommendations as well. Then you have to follow up. You will be told they are missing, and more than that, you know more. Even maybe your internal auditor hesitant, but you are more in on your own. You know actually where is lapse. So you have to collect information from your internal as well as your external auditors and facts you know, so that you can take care of whatever lapses are there, to correct them and to raise your quality standards. And also if you are interested, add value to that by your own initiative. And that's where you can say you have to review everything. Performance review we call it. Performance review by yourself, performance review by internal auditor, performance review by external auditors, and perform review by every other input which your people, stakeholders may give you, consultants may give you, you may give yourself, whatever. So there is no limit to that. Improvement never stops, it keeps on moving, and then it's improvement, and we are saying about improvement now, and which includes non-conformity and corrective action. Non-conformity and corrective action, and continual improvement. And points for considerations are: in changing business environment, process and objectives vary, to meet which requirements continual monitoring, evaluation and improvements are a must. And it's like that, as I stated earlier, that technologies keep on changing as well as business environment, which makes it incumbent upon organization to keep pace with market so as to be at required standard mark. This requires review of non-conformities. Very important point is non-conformities or non-compliance. So you have to review non-conformities, resorting to corrective actions for charting out corrective action. Resorting to corrective action for charting out corrective action, or you can say remedials of non-conformities. Such making or evolving keeps system frequently updated, and all involved personnel continue, learn and update. All leaders require share improvement responsibilities all times at currently running projects, and adopt as lessons learned on future projects as past or historical references. So lessons learned. Improvement means lessons learned. What lessons did you learn? This means every project is a learning school, every project is a university, every project is a school of learning. Every project, every activity, you have to learn methods, you have to learn queries, you have to learn work, you have to learn quality, you have to learn quantity, you have to learn specifications. It's up to you. Means when you do project, you are bound to learn. Nobody is going to teach you there, but you are bound, because already reading material is there in form of specifications, drawings, documents, methods. So you have to read that and understand that, and when you do it, you know what's right. Maybe you change that method later on. You find something is missing there, or you find that it should be like that. So that's up, your knowledge improvement. And then you can say documents necessary to support about quality system are same. Supervising service contract. Now question is supervising service contract, means previously we said construction contract. Here we are saying supervising service contract, because this service contract exists or executed between employer and an engineer. That is called supervising contract, because the engineer is asked or mandated to supervise project activities carried out by contractor, and that's why it's called supervising service contract. This is not that book, this is why something like we'll discuss later on. Then, yeah, because you are supervising in charge, surveillance in charge, you can do it only when you understand how main contract with you. You know what cost you have to pay, you know what work you have to do. So whether contractor is returning work for cost charging, that's only from main contract you can say. And of course subcontracts. Main contract and subcontracts are not different. Main contracts is in name of contractor, while subcontracts are allowed by main contractor after approval of engineer to some subcontractors of special items like electromechanical items, plumbing items, services items, or you can say other furnishing items, architectural probably. And then contractors organization chart, which has been with you along with your own chart. Supervising management organization chart means contractors organization, then your own organization. Your organization based on engineering resident engineer, resident engineer and their associates, whereas contractor site agent or contractor manager or project manager and various management levels below, many various discipline divisions, and then further down. So supervising management quality policy, that is your quality policy as consultant or as an engineer. Quality policy, we are not going to do quality policy for materials, but quality policy works. But your own quality policy, how do you consider your own quality policy, your efficient policy, and how do you relate it to contractors' quality policy? You can say supervising management chart and supervising quality policy. Then contract scope, which is very important part. Contract scope, what contract is about. You cannot go beyond that, and if you stay below that, you are not doing your duty. In that case, you don't do your duty. Contract scope must be well understood, and that's a part of analysis. Then contract objective description. Contract objective description, what contract is about, what is quality policy, and what is contractor's quality policy, contractor's project site plan, contractor's safety plan, contractor's quality plan, organizational targets and organizational commitment policy, and process descriptions, job descriptions of each position, all statutory references, all codal references if involved, procedural statements, all other required documents depending on operations. Once again, I read these important documents which you have to, must minimum, you have to understand, you have to go through, you have to comprehend this for your own efficiency. Otherwise, there will be clashes on coordination, there will be clashes on, you may write something which is based on record or based on your own conception. No consultant advise you, and also those who are involved, how much they were involved really, and how much they are out of them. Similarly, third and fourth, you can say main contract, service supervisor service contract. I can say supervising service contract, which is very important document for management angle. Main contract, subcontracts, contractors organization chart, supervising management organization chart, supervising management quality policy, contract scope, contract objective description, contract quality policy, then contractor's project site plan, contractor safety plan, then organizational targets, organizational commitment policy, process description, job descriptions of each position, all statutory references, all codal references, if involved, all procedure statements, all other required documents depending on operations. It's very brief, but we have to review all. So let's go back and see at least what we did in this supervising QMS quality management system, supervising management RC buildings construction. What we actually have gone through in this regard, we have to just have a brief review, and then we start EPC. So this is in this case we say we are talking of AnnexSL supervising management RCC buildings construction template, and what we say quality system was, it was supervising management RCC buildings construction, and also we defined an organization adopts a management system to take care of comfortably achieving its set objectives, which being in this case supervising management RCC buildings construction. Management system comprises various sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which lead to enhanced use of resources, improvement on risk management, and increase customer satisfaction by meeting product or services expectations. In this case, product is supervising management RCC buildings construction. Organizations do work on various management systems, say quality management, environment management, safety management, etc. All three systems apply in this case directly as well as indirectly. These various systems in line to ISO 9001-2008 used to work on varying management structures, causing inconvenience to interface with each other. But now all these issues shall be dealt with as framed in a common template, and that is AnnexSL, being a high level management system, has produced a common platform so as all systems that organizations adopts can be drawn based on AnnexSL designs or format. Supervising management RCC buildings construction can be easily defined within its format. Such arrangement provides many commonalities in designing system, implementation, monitoring, evaluation, and improvement by trying to eliminate conflicts that existed within ISO 9001-2008 system. Various stages related to supervising management RCC buildings construction can be covered within this template successfully. And you can see site arrangements provides many commonalities in designing systems, implementation, monitoring, evaluation, improvement by trying to eliminate conflicts that exist within ISO 9001-2008 system. Various stages related to supervising management RCC buildings construction can be covered within this template successfully. All management systems shall have single high level identical core text with common terms and definitions which can be defined within AnnexSL. High level structure cannot be changed, but discipline specific subclauses can be both added or deleted. Then we can say AnnexSL applies to all management system standards, publicly available specifications and technical specifications. You can say as well as customized requirements, then revised ISO 9001 ISN equivalent of high level structure cannot be changed, but the specific subclasses can be both added or changed As such, additions may be made where required related to supervising management tasks, building construction. AnnexSL applies to all management system standards, publicly available publicly available specifications and technical specifications, as well as customized requirements. Revised ISO 1 4000 and 4001, 14,000, say ISO 9001, ISO 14001, ISO 5001 shall all be based on AnnexSL high level structure. We are related to, in this case, all to not all skill herein. You can say this AnnexSL template shown below is only for indicative guidance to apprise the engineer about how new system shall be listed. So you can say AnnexSL template shown below is only for indicative guidance to apprise an engineer how new system adopted by ISO effective September 2015 working to produce organizational prime quality document which shall govern whole organization quality process required by business, adding accountability shareable by business and, and technical leaders, wherever requirements demand, items can be added. Demanded by ISO 9001-2015 system, which is a mandate published by ISO and without which applications, all existing ISO 9001-2008 registered certifications shall stand invalid after 3 years. So it's already it has reached time limit. Therefore, this next adoption is a must for new quality system. And in this clause 1 was called scope, common for all. Clause 1 is scope. Then clause 2 is normative references. And clause 3 is terms and definitions. And then we have 4 is context of organization. Then we have here clause 5 is leadership, which is very important part, and after that is 6, that is planning, and after that this is support, clause 7 support, clause 8 is number 10, 8 or 9, and then it is operation 8 and so we can see. Then after this we'll go to other part of this, which is very important part here. We say it's very important part, and we'll see what the important is there. Of course it is important, and let us see how it can move. As we can say EPC contracting facilities, building construction, and it is also a very important part. Better I can put that file off now. Let me see this off. Now we are talking advanced, something very advanced. Very advanced we are talking, which is till now I talked very elementarily. Very elementary in the sense of elementary in this case was just AnnexSL. We talked of standard format AnnexSL. Then we talked of clauses, what AnnexSL stands for. All these 10 clauses from scope to scope to improvement, scope to improvement dog, scope first clause and improvement last one, and example context of organization fourth one, and leadership fifth one, then planning is sixth one, and you can say support is seventh one, and operation is eighth one, and then you can say operation was eighth one, then there was the nine. I'll show you this again because this is a very important point, these clauses, so that we also remember these clauses all time. Problem is we cannot remember sometimes. Let me see clearly so that we can stay together. Let us see if it opens this file. This is Excel now, it's open, and I can show you what these clauses are. These clauses are very important one. This is number one is scope, two is normative references, and three is terms and conditions, terms and definitions, and then context of organization. Operation. 9 is performance evaluation and improvement. So what it says. So we may say these are the clauses. Now, scope to normative references, right? Scope to, then you can say text. Important was context of organization, and of course leadership, and planning, support, evaluation, etc. These only standard clauses which should be used for purpose of quality, for purpose of quality assurance in the construction, or else, and then you can say also environmental related issues, and everywhere can be used. We have reviewed about document about stay. So we have to go to higher point after learning what we will learn. These clauses which we read are actually very important one, and we should understand them very well. Scope, second one is which we said we lot in this. Remember the first one. You should remember, I forget all time. That's my weakness. Let me go back. It will take a lot of time here. I made the mistake to close that file. It should not be closed. So it is that one, and it's easy to remember. Yeah. See, scope and normative references. Scope and normative references, terms and definitions. So this is the clause scope, normative references, and terms and definitions, context of organization, leadership, and planning, support, and operation, performance review, and improvements. This is what we say are. So you can say, now I'll close this file. So terms and definitions, you can say. So scope is very common, and scope is very common. Now these are defined clauses by ISO 9001. But it is not exclusively what they say. They only say you maintain the sequence and you can add. There's no restriction on continuous education. It's now up to us how to comprehend quality system in writing. Nobody is going to teach our country. So we are going to explain about EPC. We talk of contracts, we talked of general contracting, we talked of construction contract. We are talking of contracts. We know what is the importance of contract. So particularly those people who are busy, who remain busy on such projects of EPC or construction or others, this talk is addressed. I at length discussed about structure, annex, annex SL for construction projects, for design and construction projects. Right. Alright, so we can move further now. We have seen what happens in construction case, and we have seen what happens in supervising case both. Because on same building, same project, there's a person to supervise that. Let us now take care of ourselves and go further for our studies. In this case, I consider this a study only because study is important point in every case. Study is very important point in every case. That is very much important. Whatever we consider all about this. Now, we are dealing with EPC contracting facilities and building, and that is actually EPC. It includes full work. Nothing is left to designers. Nothing is left to on employer. Generally, whole work. Whole work is contracted. Contracted whole work. This is so easy. EPC stands for Engineering, Procurement and Construction. Engineering, full scale engineering production. Now, when we jump onto EPC, we jump onto whole different world. We jump onto a contract with a system of very powerful company, very powerful contractor, because expensive to it. Yes. Come on, tell me what you want to say. We are going to do this very important topic. It is, I just want to comprehend on this very important one because it impacts on major projects of billions of dollars, and that also, you know, because design element is involved. In construction, quantity design on all the site, if you're in a hurry, we make such. Now, sometimes we say if you take contract based on design lines, what we are going to say, can you think of? Think of. It is some wonderful word we are talking of. It's wonderful in the sense that complete responsibility, you may say, design, drawing, technical viewers. What to do now? It says AnnexSL ISO 9001 2015 QMS company plus EPC contracting facilities buildings. EPC contracting, and we can say about this. Company EPC contracting facilities, buildings construction. An organization adopts a management system to take care of comfortably achieving its set objectives, which being in this case winning from certain plant promoting company and EPC contracting for facilities and related building construction. Uh, uh, Management system comprises various sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which lead to enhanced use of resources, improvement on risk management, and increased customer company satisfaction by turned out by relatives. Yeah. You may say, again I read, an organization adopts a management system to take care of comfortably achieving its set objectives, which being in this case winning from certain, yes, a building of a. So what we say now? So management system comprises sets of procedures for charting out and implementing various operations or activities so as to successfully reach its intended objectives, which lead to enhanced use of resources, improvement on risk management, and increased customer company satisfaction by meeting product or services expectations. In this case, product is EPC contracting facilities and buildings construction or certain plant facility. Plant facility, you know very well. You know, when no. In case product is EPC contracting facilities building construction for certain plant facility, which facility being promoted for implementing planted patented technology through defined thermal photonic equipment. Which facility being promoted for implementing planted technology through defined chemical process on plant producing required products. I repeat this very important point. Scope of this is product is EPC and contract facility and building construction for certain plant facility, which facility being promoted for implementing patented technology through defined chemical process on plants producing required products. Organizations do work on various management systems, say quality management, environment management, safety management, security management, etc. All such systems apply in this case directly as well as indirectly. These various systems in line to ISO 9001-2008 used to work on various management structures, causing inconvenience to interface with each other. But now this AnnexSL, all these issues shall be dealt with as framed in a common template. AnnexSL being a high-level management system structure has produced a common platform. It's produced a common platform so as all systems that organizations adopts can be drawn based on AnnexSL designs or format. EPC contracting facilities building construction can be easily defined within AnnexSL format. In this case, intentionally both promoting company and EPC contractor management have been tried to be included in one AnnexSL format only for purpose of clarity to understand real working and such projects. Though practically both promoting company and EPC contractor adopt their respective system separately. I read this again. In this case, intentionally, both promoting company and EPC contracting management have been tried to be included on one AnnexSL format only for purposes of clarity to understand real working on such projects. Though practically both promoting company and EPC contractor adopt their respective systems separately. Such arrangement provides many commonalities in designing system, implementation, monitoring, evaluation, and improvement. By trying to eliminate conflicts that exist with 2008 system, ISO 9001-2008 systems. Various stages related EPC contracting facilities and buildings construction can be covered within this AnnexSL template successfully. All management systems shall have single high-level identical core text. All management systems shall have single high-level identical core text with common terms and definitions which can be defined within AnnexSL. High-level structure cannot be changed, but discipline specific subclauses can be both added or changed. As such, addition may be made where required related to EPC management system standard, related to EPC contracting facilities and buildings construction. AnnexSL applies to all management systems standards publicly available specifications and technical specifications as well as customized requirements. Revised ISO 9001, 14001 and 45001 etc. shall all be based on AnnexSL. High level structure were related to in this case, though not included herein. Now this AnnexSL template shown below is only for indicative guidance to apprise an engineer how new system adopted by ISO effective September 2015 work to produce organizational prime quality document. We shall govern whole organization quality process required by business, adding accountability shareable by business and technocrats leaders. Wherever and whatever requirements demand, items can be added as sub-process, but no deletions can be made. Purpose of this template is just to project quality track demanded by ISO 9001-2015 system, which is a mandate published by ISO and without which applications, all existing ISO 9001-2008 registered certifications shall stand invalid after 3 years since September 2015. Of September 2015, so it's already gone. Therefore, this AnnexSL adoption is a must for new quality system operating globally. Format is same as we said, scope and references, scope references, and we can say terms, and you can say then text of context of organizations, leadership, planning, support, operation, evaluation, improvement, right? Say scope. Normative references, we said scope, normative references, terms, and then context of organization, leadership, planning, and then you may say support, operation, and then you can say Evaluation, performance evaluation and improvement. These are standard points, standard clauses we have to keep in mind while designing whatever AnnexSL. These points cover whole process of quality organization. Well, this is okay, something is standardized, but these fill up we have to do depending on your knowledge of that project or that organization which take care about this. As I said before, project and operation have different strength, different world. Project has very small duration in comparison to work. When we say when we say EPC, it is altogether a different world because of freedom of design. In other one, in construction, design was responsibility of that organization, but this government is. EPC means you have to design yourself. So So we are going to do a very important point here is little disturbance in between. So I'm sorry for that. but no problem. We can continue on this. Little gap was created, 10-15 minutes difference, because I was looking for some reference which was forgotten earlier. I apologize for this disruption. Now EPC, which stands for Engineering, Procurement and Construction, and particularly buildings are involved in this. Buildings, I mean all sorts of buildings. You can say scope, some related information, some related introduction. Fortunately, I had an opportunity to work for many years on some petroleum related projects during my job career in Gulf Council countries called GCC countries, which attained experiences supported me to contemplate few points preferred to reflect certain basic description about industrial green projects so that it may be supportive to understand for those readers who are not convenient or conversant with plants, facilities, projects, component and requirements. But these descriptions have been drawn from those projects which do not have any relation to other projects. Therefore, while dealing with writing context of specific projects only involved processing trains related to plants facilities, engineering technologies should be included based on company design right product patent. Such quality objective scope is required to be written by company only. Company herein means an organization which is responsible for this patent product entirely. In all respects, produce, feed, designs, detailings, execute, supervise, approve works, and finally commission plant based on performance results. I repeat, company herein means an organization which is responsible for this patent product entirely in all respects, that is produce, feed, FEED, which stands for front end engineering design, designs, detailing, execute, supervise, approve works, and finally commission plant based on performance results. On such major project, company is designated as a prime representative of state on, or generally such organizations are state owned or could be in status of PPP, but rarely PPP, public, you know, private public partnership participation, but rarely PPP. Company awards design and execution works to certain prime contracting organizations on scope status, EPC. Prime contracting or prime contractor further sublets civil works, electromechanical, security, CCTV, SCADA, supervising control, acquisition, you can say supervisory control and data acquisition, that is called SCADA, supervisory control and data acquisition, and CCTV's closed circuit television, and various other disciplines to approved subcontractors who execute respective discipline in conformance to company and prime contractors' requirements. Company head acts as engineer to be contractually responsible in all respects. Example for such companies being Qatar Petroleum, Abu Dhabi National Oil Corporation, Aramco, etc. Now, scope backing. An industrial development, an industrial development processing facility formation. It is necessary in interest of economical development that an industrial project should be efficiently promoted, for industry being backbone of a nation, which keeps nation moving forward, improving quality of life of its subjects. Sooner is industry created, better would be prospects for economy, nation. Therefore, value engineering should efficiently be applied to products, goods proposed to be facilitated to enable consumer be delivered with avail avail most economic and quality products. When we talk of industrial development, we target to achieve potential industries for long term production of intended products that may cost in billions of dollars. In its concept, front end engineering design, front end design execution would certainly quantify to considerable quality, cost, and time in every respect. All types of major industries require development in line to meet public or economy requirements of nation or of internations. What class of industries should be promoted for modernization depends on various relevant criteria as well as development value engineering. Oil and gas, power, steel, aluminium, water resources, nuclear energy, and many other infrastructures do require promotion not only for an exclusive sake of commercial business, but also for sake of social, economical development and sustainability. It has been tried to include various procedures or steps in common that are required to promote onshore, downstream petrochemical facilities, which is meant for meeting national and international requirements. Byproducts extracted out of natural products. It should be kept in view that promotion of certain potential industrial unit is a national planning job, which must be based on thorough feasibility studies and research, operational research relevant to long, many years consideration. Since since promotion of such development affects to some extent utilization of natural resources available within earth store that should not be blindly explored, but a balance must be maintained for future generation to come. Therefore, adopted decision must be based on certain criteria that available resources may not be exhausted, at least at fast pace by current generation. To affirmatively maintain sustainability, explorations must not be solely destined to just making money out of natural resources. Policies decision, authorization, technology promotion. Involved government should promptly work out relevant policy in a positive manner. For time is extremely important factor that should be used properly to get optimum use of project. Provided adequate funds are available within allocation of budget or institutional financial borrowing should be made. Value engineering should be properly studied by experts to reach a conclusion that proposed product shall be processed, imparting no adverse impact to existing environment, shall be most economical in production cost, shall be easy to be transported to consumer, market or end user facility, shall be most beneficial to national society from every aspect, view of cost and economy uplift, as well as shall promote use of green technology and provide benefits to all people located globally in long term. A right and reliable charter must be constituted at very initial stage of conception for a permanent reference, including various information such as aim, target, policy, political impacts on area and nation, rehabilitation and other bad effects, requirement of additional infrastructures, generation of employment opportunities in both stages of promotion of project as well as its operation and maintenance, technology, stakeholders, current value, earned value, long run value, continuous benefits, expected risks of all sorts, whether or not other alternative products could be promoted to achieve better value engineering. Sustainable development means state of an art technology that has been developed for application on projects which technology does not go against existing requirements and neither impacts adversely on availability of natural resources when future generation may for sure require all such resources sources. This means that both both current and future generations both current and future generations should enjoy availability of all natural resources as well as friendship with green technologies without compromising with possible effects of nature. Value engineering plays a significant role to many extents when use of technologies promotions is concerned. There could be options as far as technologies are concerned, which options based on considerable factors and various aspects would decide which technological application shall deliver better results on proceeds of product in long term as well as in short term. Short term facts could be consideration of land cost, or design considerations, construction cost, product, environment, friendly impacts, transportation cost, availability of experts and artisans, etc. While long-term considerations would be maintenance cost, life of project or facility, safety risks involved, public risks involved, future availability of alternate, easy and economical technologies that be currently under research stage. Facility requirement, value engineering based effective application, effective technology, product and user requirement, necessity, approval and financing, international competition, cost effectiveness, safety, health and environment, tenability, sustainability. Should these points be met by proposal, project may be given a go-ahead subject to meeting other engineering criteria. Once value engineering factor has been included into plan consideration with full integrity and incorporation of provisions in this with national and international policy for such evolutionary developments, there remains no meaning to delay projects, but projects initiation by charter authorization by respective stakeholders should be done. Finances have to be allocated to statutory requirements to give a go-ahead to various phases or stages of project development so that delivery be made in defined time for follow-up operations for consumers or end users. Since facilities demand incorporation of inputs from various disciplines, personnel, material and equipment with licensed technology, every criterion must be kept in consideration for a final startup. Facility, justification and feasibility. Environmental sustainability, cost viability in long term, nationally beneficial to add to economic growth, multi-purpose approach and creation of employment, casual as well as regular. Export potential of product, processing technology and availability of raw or natural resources materials, adequacy of availability of terrain and routes, selection of planning and execution mode, availability of expertise and experts along with all other interrelated professionals, availability of all human and all other resources, their original sources, international agreements for bilateral trades with producing nation, finalization of design rights, copyright, process technology, license, agreement on various contract forms, adoption, agreements on international workforce migration for projects, public-private partnership or participation or government responsibility or international joint ventures. Availability of relevant trade zones based on subsidy for industrial promotions in general, public interest for long-term construction and operations, certainty of return by reliability proceeds, so you can say certainty of return by reliable proceeds after a defined set of years, or an assessed duration after which investment is made an asset for remaining life of plant facility. Component elements of certain processing plants facility inclusion in general. Availability of natural gas or oil fields from where natural resources are being tapped out from offshore locations of various seabeds, founded rigging platforms, allowing risers leading pipes to upstream onshore slug tanks. Availability of all well-equipped facilities of shipment, platforms, injections and risers for raw oil delivery from seabed. Availability of land for required downstream processing area onshore with acceptable terrain that may be used for operating complete chemical process engineering applications used on well-designed trains, as well as transportation of proceeds, processed products and byproducts to specifically located outlets leading to consumers' locations. Plant processing scheme and technology both for greenfield and brownfield, spelling error, sorry, in greenfield FIELT should be, and brownfield supported with authorization by legal license valid for defined periods. Liquefied natural gas LNG tanks made of cryogenic steel, RCC PSC containments with spillage and other components etc. for storage purpose at considerable minus temperature. Plant processing trains elements complete with detailed descriptions of heavy and light industrial equipment. Utilities areas element for integration with plant equipment. Off-sites element for sub-assistance to aforesaid. Intake piping system arrangement for circulation and delivery into plant equipment for cooling purposes, cooling process and application. Seawater basin for storage of seawater to be used for cooling purpose during various processes. Delivery of cooling water to plant and then recirculation for further cycle of processes cooling. Piping, pipe supports, pipe sleepers and pipe racks for product transportation and relevant handling operational activities. Service air and instrument air circulation, piping, chlorination plant with complete system package for purpose of chlorinating water for supplies to plant use. Storage and warehousing for physical handling of subsidiaries. Drainage infrastructure from plant to receiving basin. Drainage infrastructure from plant to receiving basin and then to outfall structure through discharge channels duly provided with metal lugs and channels. Ditches completely lined to convey out to final discharge stormwater from various catchments areas of plant. Complete package drainage system for oily water, acid water, oily water, acid water, dusty water, sewage, etc. That comprises of hundreds of RCC manholes, many kilometers of pipelines, connection with such manholes and chambers, leading and disposing to sewage treatment plants, STPs. Water line for whole site for various purposes, including loss prevention, that is fire suppression, firefighting with fresh water, as well as with backup seawater supply from seawater reservoirs or elsewhere. Cooling water line provision throughout whole industrial area zone, taking in water from intake at sea, supplying to industries, and then through return headers, discharging to sea directly after being supplied once, as well as employing cooling water system technology to recirculate used water while only make up water to be supplied. Pipe supports, pipe anchors, general anchors, big anchors, thrust blocks placed at various defined spacings. Pipe supports to be connected to sleepers, and direct supports using structural steel connections for both direct clamping as well as achieving sliding action to make up for expansion, which supports are often considerably heavy units for considerable size pipe. Electrical heat tracing provision, electrical heat tracing provision for piping system carrying minus temperature liquid or gas to keep maintain pipe on required temperature so as not allowing freezing of material. For example, sulfur gas can freeze within pipeline. Heat tracing works dedicatedly encompassing pipes, transferring thermal energy to pipe and then to internal available gas at minus temperature so that gas does not freeze in pipe but keeps on flowing at specified temperature and velocity. Non-blast buildings such as administration as well as amenities buildings elements for facilitating operation and maintenance as well as consumer supply, the receipt station that should contain various offices with access controls, electrical main station, substation, switch gears, package substations, pump houses, guards houses, visitors areas, ring main units, transformers, heavy duty armored cables, centralized control to all such supporting on-site or off-site buildings for electrical distribution system and security system. Blast building such as central control as well as operations building to control whole plants operations from one single location, monitoring all engineering disciplines, plant surveillance 24 hours, 7 days a week. Consumer receipt station to be used by consumer delivery control located at gate house, intake pump houses and other processing pump houses at various locations duly integrated for controls all over plant facilities. Water retaining structures such as below ground sumps, receiving basins, drainage channels, outfall discharge to sea, site security arrangements fencing, surveillance, and by installation of CCTV with state-of-art technology, site telecommunications of all sorts for efficient use by operating personnel available in all security zones, spread over entire facility. All loss prevention arrangements, including internal and external firefighting, all arrangements to cater for fire emergency, blast emergency, or seismic emergency. Fire tender station is significant to cater for this facility. Adequacy of plant and non-plant area of roads and paving, maintenance tracks, road crossings, utility crossings, road culverts, pipe culverts, transit manholes, control defensive traffic, movement and circulation, etc. Soil erosion protection for all machines and equipment so that all these equipment should not get damaged due to possible negative impact by heavy dust laden storms. Facility byproduct plants as extensions and all required elements for that. All related civil engineering disciplinary structures for buildings, sheds, equipment vessels, as well as other processing and non-processing equipment. Vessels such as cracking furnaces, wash water structures, cracked gas compressors, propane compressor, ethane compressor, boilers, auxiliary boilers, various types of spheres, steel tanks, fuel towers, rotary equipment, reciprocating equipment, etc. shall be made part of plant with necessary foundations. For these elements or components to be constructed in line according to defined requirements. Massive concrete block, massive concrete blocks such shall be required for many such major foundations to found for heavy vessels. Civil engineering foundations structural requirement shall vary from a simple machine plinth to independent footings to combined footings to stiff footings to raft and piles as well as massive block foundations. Concrete shall generally be low heat producing cement based manufactured by using microsilica or GGBS is ground granulated blast furnace slag replacement cement up to 70% extent and also pulverized fly ash PF construction. Jump over existing plant circulation road be constructed using structural steel, cathodic protection both critical and non-critical requirement for centralized corrosion control of plant reinforcement from a central control sacrificial node station. Central control sacrificial node anode station shall also be provided for long-term corrosion monitoring and controls, respecting reinforcing bars. Earthing provision for all individual structures, equipment as well as network, colored green, red, etc. Covered cable trench RC vault buried directly to ground or cable duct shall also be included in design forming a major part of certain facility. These ducts shall be coordinated to various interface crossings requiring site resolutions to protect plant supporting services interface clashes. Heavy duty concrete pavement shall be provided all plant areas for required purpose. Office maintenance respecting machines as well as movement of heavy vehicles. On other areas where no pavements included, stone aggregate shall be spread and compacted to avoid soil adverse impacts effect on all vessels or equipment. In addition, all important administration areas shall be allowed to an attractive soft and hard landscape architectural provisions. Access security arrangement shall also be made with automatic controls using card readers or fingerprints scanning, etc., and installation of CCTV for continuous control and records. In- Inclusions of flare towers and radio masts is also contemplated. Process areas means areas within which chemical trains work to run defined technology to work over adopted processes. Non-process areas are those which are outside limits of process areas and support process areas. I think process areas means areas within which chemical trains work to run defined technology to work over adopted processes. Non-process areas are those which are outside limits of process areas and support process areas. Administration areas is that where are recommended where are accommodated buildings and required facilities to meet plants demands for administration and maintenance support. Admission areas is that where are accommodated buildings and required facilities to meet plant demands for administrative and maintenance support. Administration area may comprise of administration building, amenities building, warehouse, stores, fire station, etc. All structures of whatever materials are designated blast resistant buildings which are located within process areas. All structures of whatever materials are designated blast resilient buildings which are located in 200-meter range from process areas. All other structures of whatever materials are located away from 200 meters from process areas to within 600 meters range are designated non-blast structures. Well, I've gone through this list of components, which is very much encouraging to understand at least what could be components on certain facilities, which is much significance and importance in this regard, and we have to understand that point very seriously, because if you don't understand that point, you can't understand this program. It's very important program for everybody, that we should be clear about this in one way or other. This is required. We cannot escape such information. It's very, very important. Actually, it's too long paper, and I just wanted to explain something about this, and that's very important one. Although it's time now, it's already about, I can say, more than 3 hours 45 minutes. It's not easy all time to do whatever you want to do. Time is of significance, and we have to learn also. Well, I had intention to continue, but I just want to, because it is EPC talk, not an ordinary one. It is a responsible procedure. EPC contracting is very high profile contracting system, where you are not only contractor but also you are a designer, It's you are responsible for totality of project. You can say whatever quality input you give there, quality input you put in there, that is very hard, very smart, very flexible, very useful, very commandable, and with surety and security complete. Not one engineering is involved. I think generally five or six engineering branches are involved in such projects. You can say surveying, architectural, geotechnical, structural, security, machine related means mechanical, electrical, and various others. You can say technology is involved, secrets are involved, and even if such projects are prohibitive, means non-accessible to citizens, so such projects can be called controlled projects or classified projects, you may say. People know projects are there, but details are not known. Coordinates are different, coordinates for public and coordinates for plant. Both can be designated differently. You can say coordinates that we use on projects for purpose of execution or for prosecution can be called plant, can be called relative coordinates rather than plant coordinates or working coordinates, you can say, and real coordinates would be different. These are for purpose of protection only. EPC, though I think such jobs are higher than EPC because of technological involvement, vessels involvement, processing involvement, chemical engineering is very much important. All such points we have to consider on such projects. These points are not easy for a fresh people or even for senior people until you face them abreast in field, and that's where you can understand world of building engineering is quite different than world of plant engineering. Of course there are buildings in plants engineering as well, but not high rise. Ordinary buildings like CCB, you can say central control building, which is blast resistant building, and like many power stations or substations, which are both, which can be generally said blast resilient and blast resistance. If these substations fall in area of processing plants blast resistant while it's off, you can say it's off to say more than half kilometer, and these are not, you can say, blast resistant substations. Similarly, control buildings like say administration building, warehousing building, or other amenities building, which are ordinary buildings. So there are various kinds of buildings, classes of buildings: RCC, complete RCC buildings, and framed RCC building with all normal conditions, and infrastructural road within, and you can say kilometers many services, utilities, and reservoirs, and all that we have gone through. These all components are very important. Without these components, you cannot say the plant facilities can work. And then so much is there in such areas. We'll take up all these issues as much as possible to my experience. I'm not very experienced, in fact, just I try to observe because I was in coordination of such project sometime for many years, and I always take interest in that to poke nose everywhere, you may say, because of course it's widespread site, means always wide kilometers by kilometers, but not you can say structural steel is very dominating factor there. Structural is very dominative. RCC is dominative, and then and you can say foundations are dominative. Heavy structures are dominative, or you can say cabling, electrical, high power voltage is very dominating there. So utilities are dominating there. All works of heavy nature contribute in creation of such facilities, which must be taken care of. It's not exclusively structures of buildings, but heavy structures where you have to, and then before you have to make up area also. Before starting such projects, you have to see existing contour of ground and proposed one. So there could be many meters of backfill as well, or makeup ground. So that is still millions of cubic meters backfill could be there, because such projects lie near sea, and sea are always at low level, and you can't use sea level for purpose of such projects floor level. So you have to raise layer by many millimeter, many kilometer, I mean many meters, which is very important point. So of course you can see in such projects record drawings are less valuable, but not that much. You have to do a lot of work of survey, geotechnical survey, geographical survey, and other surveys, and then soil exploration before doing that work, and also doing during work during means it's a kind of multidisciplinary requirement which must be understood very well. And that was really something great I wanted to share with you, because without this, we cannot go ahead. It's really interesting that that such project of EPC nature I'm discussing with you. Maybe you people are not feeling happy because either you have not experienced such, or for you maybe this is a kind of story, imaginary story, but it's not imaginary. And you think I'm a civil engineer, how can I talk of everything? That's different. But I was civil engineer in the beginning, but process of my life, career, and my movement of during my career made me to encroach on enter in different fields, due to my being coordinator, due to my being office engineer, due to my being site engineer, due to my being, you know, a technical writer. You can say in all these positions you come across various contract documents, contracts, and technical specifications. And you, if you take interest, you can get up. It's not necessarily learn in your educational time. You can learn your practical lifetime. That's what is very very important point that understand. And it did. It worked very well. I don't mind all this as far as this is done. Really appreciative administratively as well as technically. Though I am a learner, still I'm a learner, and I try to learn. While I'm talking to you, it's also a time of learning. What response comes to me, or it doesn't come to me. Maybe you do not like anything. I don't write answers. No problem. It's up to you. But I have my duty to do job. I just try to disseminate. I learn from field. I'm just trying to disseminate among my colleagues, among community, so that they may try to learn, because forum is available, Facebook is available. This allows this facility, so they make use of that. It's best to know people and to let them know about you. You can't see my face. You may not like my face, but face is not important here. Your performance is important. Means I'm trying to share with you what I learned, because one day I will die, and if you give people something which gives them some benefit of understanding and knowledge, I think that's best service to humanity. And it's not for one nation, it's for whole world, that such professional talk must be made, and it's being done, doing the service to you, just for sake of development, sake of humanity, or sake of everything that's required here. And that's the best one. No, nothing else can be done other than this in professional development way. And that's the best thing I can say. I can say we do or we don't. That's another point of view. And if you do that, it's good. If we do something like that, it works. It should work. What's wrong with that? Well, I think now I am taking off until next time. In next talk, we'll continue with this. I think each page is. I'm not sure which page is it. Let's see which page is this. This is page 14. So we'll review this up to page 14, and we also review other talk we made, and then we'll continue on this. It takes some time to review and all that. So please have patience. No problem. And I'm now closing this with your permission.